Yeah, so first problem is like a number of submatrices that sum to target. They are given a matrix and a target you have to return non-empty submatrices that sum up to the target. And submatrix, this is the set of all the matrix this with which are the boundary, like what is it? X should lie between x1, x2, y should lie between this. And these are different if they have some coordinate that is different. For example, x1 not equal to x dash. So target is here 0, right? So one is the entire matrix you can take, and single matrix also, the 4 1 cross 1 matrix. Okay, sorry, entire you can't take. My bad. I mean the corner ones you can take, right? Let me annotate this parts. This is one, and next is like if you come to this regarding what is it? This one. 1 minus 1 minus 1 1. You have to get 0, right? So this is 1 matrix, this is 2 matrix, this is 3 matrix, this is 4 matrix, and matrix entire itself is 1. So this is where 5 comes. Yeah. So what do you guys think? Am I audible? Yeah. So it's like what is it? Similarly, like 1D prefix sum, we can do this problem also, right? So am I audible or like?
Yeah, you are audible. Yeah.
Sure. So like we'll do the what do you say prefix sum linearly, and then subtract column wise every time, right? Like 0 1 0, and then 1 2 3, and 0 1 1. So this would be 1. And now what do you say? We can even do the like take 2 columns every time and just subtract those two and maintain a hash map and just check if that sum has already occurred. You mark its value over there, and after that we can pick up the value like what we used to do in 1D prefix sum, right? If we have to find the subarrays, what is the, I mean, whether this subarray correspond to a given target or not. So we used to take the sum minus target. If we see prefix sum, do the prefix sum minus target, and you find that key in the hash map, then you record that index, right, and then take and subtract from the current one.
So is this a brute force that you're discussing?
Yeah, brute force.
Okay.
No, brute force would be like generate all the possible submatrices out of it, right, and check whether its sum is equal to given target or not. All the elements.
So this is an optimized version. So you're saying you actually construct a prefix matrix of the whole one, and then you go row wise.
Yeah.
Sorry, or column wise. You are saying, right, for each and every row. Is that?
Columns. Yeah, exactly. You are going correct. Yeah. I'll
Okay,
just
and
take.
then for okay, so for each column you start with one row, Okay, for each row you start with a column from the zeroth column, and then you go on doing that till the last column.
Yeah.
Okay. Yeah, so okay, so you traverse the array linearly from left to right.
Left to right. Yes.
Okay, but then how do you find, you said, the target in that case?
So I said like every two columns I'll take, and I'll maintain a map also, right? If I find that the difference is same, which I've already seen, that means from that index to this, it will give me a proper what do you say coordinate.
Okay, so now if I have to first thing, if I have to create a prefix sum of this current matrix, which is an example one.
Yeah.
Okay, so is the prefix sum going to be what is it going to be? Can we write it down somewhere? So
Yeah.
you just said it, right?
1
Okay.
2 3 0 1 1. Right. Linear, I mean, every row prefix
Okay.
sum first time, right? Every row.
So in
Not,
this case, it will be 2. It will be 3 in the middle, no?
I'm not following 2D prefix sum. That I got what you're saying. I had these two and then add the current element minus this. That you're saying, right?
Uh-huh. So that is not you're trying to follow.
No. I'm first doing a linearly prefix sum for every particular row, given row. Like for this will be 0, 0 plus 1 is 1, and then 1 plus 0 is 1. Then I'll go 1 plus 1 is 2, 2 plus 1 is 3. And then 0 plus 1 is 1, 1 plus 0 is 1. And now I'll take two columns each time and subtract from this column this value, and then check whether the value is already occurring in your hash map or not, to get these intermediate, these matrices.
Okay. So now you have this 0, 1, 1, 1, 2, 3, and 0, 1, 1. So you will start from row for 0th row and then the column 0.
Yeah,
And then you will subtract the column 1 from column 0.
0,
Right?
yes, you're correct. And
Okay. You
again,
subtract that. So you will get a
next,
difference. Sorry.
no, I mean, every two I'm taking, like these two you'll take a difference, store it, and again these two you'll take a difference, like keep on doing till the entire column is over.
Okay, so initially when you come to the 0, you don't store anything. You always take a difference. But okay, but then what about the first column?
Your first exception will be I mean, first you can't subtract from the previous. So in that I'll subtract simply 0, simply 0, simply 0, so that it remains as it is. Because there is nothing on the left of it, right?
Okay. So
I
that
think
is
code
your
will make
range.
more
Uh-huh.
sense. Code will make more sense.
No, but actually, let us actually walk through this approach very clearly, then we'll
Actually,
go there.
I didn't get the. So, what is a submatrices when
Like
we
in
say?
this one submatrices, one target 0, there are four
Yeah,
answers.
that's one cell, right?
That is submatrices of 1 cross 1.
Correct. So, if we have more, like, can you take other example where we have more elements?
Yeah, like 1 minus 1. The second one I'm taking. What is that? 1 minus 1 minus 1, 1, right? So there are minus 1, 1. So the 0 can be either you can take this, which will give 0, this will also give 0, this will also give 0, this will also give 0, and the entire matrix will also give 0. So
Yeah,
5
that
such
is
matrices are there.
five. Yeah. So here, how are we? So the brute force will be like take all the elements with each other element and generate all possible submatrices.
Brute force you're saying.
Yeah, how will be the brute force for this? Like just thinking out
You
loud.
generate all the possible matrices.
So
Generate all possible matrices and just check the sum of the elements equal to target or not.
to do that, we it will be O is will it be O of n square?
N square for running all the elements, and again inside you'll have to run n square. So n to power 4 it will be, I think.
Okay. Yeah, we'll have to take the sum of n.
Because every matrix you'll take and again you have to run. Yes, and what you were saying?
Mhm. Yeah, so you said that you start from the 0 means minus 1 column, no, in that case, because you had that 0, 0
Hmm.
previous to it. So you start from that column, then you subtract for the first column, okay, and then you go
Hmm.
for uh, then you keep on going adding one column to that.
Every time, yeah. Like next time, then I'll take these two and take the difference, and you'll add again. If you have any other row, I'll take the difference of these two. Not in this,
Oh,
in the prefix sum which I wanted. On this one, I'll play
but you will have
0,
to do
1, 1.
that for each and every column, right? So you start with
Exactly.
the
Yes.
minus
Yes.
one. So that will be an n square for that particular column at least, correct?
Column. Yeah.
Okay.
So can it be done less than n square?
No, I'm actually trying to follow the approach. That's it. I'm not even uh, thinking about the optimization.
Like, can you explain what is actually getting stored in the hash map?
hash map, I mean, this, you obtained this first. Okay, I printed the matrix. I'll show you there, I think.
The row prefix, I understand the prefix. Yeah, I think you were trying to solve it using that subarray logic, right? Subarray kth, in which we store in the hash map and then check. You're trying to use that logic in the 1D array. You're trying to do that in 2D array. Like, just wanted to know what are you storing in the hash map?
In hash map, I'll be storing the difference between those two columns, whatever new matrix that I've obtained. Now consecutive difference I'll take, right? And store the key as the difference. And whenever next time I see the same, what do you say, same sum, then I'll pick the coordinate corresponding to that and then.
Okay, so after making that prefix row that you did, then you are starting from for column -1, you will be storing 0. And for column 0th column, then you will check that whether this hash map, whether this value existed or not. Like when you come to column number 1, you will subtract it from column number 0 values and will store that into the hash map basically.
Hash map, exactly. And keep the count, like if you see, I've seen the repeated, I mean.
Yeah, so Shashank, you're using that method, no? Maximum sum subrectangle where we have this cadence of
Cadence.
NQ1.
I'm actually following that also. We have no one, I mean, 1D array is given and you have to find a sub array whose target is equal to this, right?
Yeah, I got your point. Yeah. So it would be n cube, right? Your code's complexity.
Yeah, it will be n cube because 2 for loops for the every that what you say, a row, pair of columns, and inside that again one for loop will run for taking the some, what do you say, going through the calls. I'll show here. It will make more sense. It will be n cube. You are correct.
Yeah, the 1D array thing. Yeah.
1D array, exactly. Or what I think Santosh was trying to say, to do a 2D prefix sum. I think what he was trying initially, isn't it, Santosh? That's why you said 3 at that point.
No. See, I was trying to see the way you first, you're drawing on that, the very first one. So this is the one what you're showing on line 10, 12, 13, right? So that was the 2D prefix sum you started with. So I was trying to understand how you can use this and find that target value, because that would be more difficult, right?
Could you simulate an example completely, Shashank?
Yeah, sure. I think let me go through the code once, and after that I'll simulate the example. Like I'll get a flow. Like I haven't. It's not a recent code. That's why I have the matrix over here, so I'll show you.
Okay, no problem.
Yeah. So this is like the normal which I showed. By every row you will what you say 0, 1, 1. I mean every row I'm doing the prefix sum. Every row prefix sum, and you got this matrix. Now all the operations will be performed on this matrix itself. So what I told you, each time what you go, this for loop, whatever number of columns you have, those many times this will run, and every time it will pick two columns, right? I mean, 3C2 pairs you'll have, 3C2 pairs out of this, right? So what we are doing for every, let's say these two columns are that initially I took. So I created a map out of it, and for the 0, like what you say, there is nothing on the behind this, like -1, right? You got this side. Nothing is there. So I'm initializing 0 with 1 initially, and current sum is initially 0. Now what will happen once I selected these two columns? Now I'll go row wise. You got 0, 1, 1, 2, 0, 1. That way I'll go. And what I'll do, this is for checking the condition, that one. If you are at this row, you can't do I -1 in that case, right? For that you will take directly the value as 0. And whatever the prefix sum you have obtained till now, 1 minus 0 you'll do, and you add it to your current result, and you check whether current minus target is already present in your dict or not. If it is present, then you directly take the value from there. Or if it's not present, then first time if it's occurring, then corresponding to that current, you increase the frequency by 1. Now I think let's go through the simulation, right? So this is the matrix that we obtained, right? Now what will happen? For these two rows I'm taking. For 0, I'm initializing it with 1, right? Now your current will be what? 1 minus 0. So for this 0th column, for this column, what will have? It will be same as it is whatever we are having, right? There won't be any change in that.
Yeah, because initially the first column I and on line number
Yeah.
18 also the same column, right? So
Mhm.
both are the same.
Same, that's why, yeah. Because this part will be 0 for the first one, right? Because I is not greater than I. I think it should be 1. It should be greater than 1, right?
So what is that? If I is greater than what
1,
was?
then initially it was 0 here. So 0 won't work, right? Because, okay, yeah,
It
0 will
should be
work.
greater than.
No, it's correct, it's correct. If it
Yeah,
is
it
greater
should
than
be
0,
greater
that
than
means it
zero
should.
only. Yeah.
Yeah, yeah, correct. I made my bad.
Oh, I only index, Okay, that
Yeah,
is
yeah.
fine. Uh-huh.
This part is doing that portion. This total current is doing this. Every, I mean, 0, 1, 1, 2, it will take this and subtract these two. 1 minus 0, you'll have 1. 2 minus 1, it will have 1. And 1 minus 0, it will have 1, right? And now it
Uh-huh.
will go into the hash map and check if that sum is already present, it will pick the uh, this value, what it like how many pairs you have seen previously. I
Okay,
mean,
so that dict will be a frequency map which will have a count of all the values in it.
in it, yeah.
Okay, and then you're trying to find in that dict or that map how many such current
Pairs
sum what you already had.
have.
Current minus target. Okay.
Mhm. It's like 1D prefix, like what we do. If you got x
Right,
minus
right.
target you do, and you find it in your map, right? Then you increase its frequency or maintain its index if it is of length. So same thing is being done at this portion. And
Okay.
every time you'll have to create a new map for every 2 rows because I'm initializing every time my map.
Mm-hmm. Yeah, so the way you are actually from line number 22, so
Mhm.
all the way to 25. So you are trying to go through all the rows for those two columns, whatever you have selected.
Yeah, all the rows for the given 2 columns.
Right. So then after that, when you're done with those two columns, then you move to the next column. Okay, keeping the first column constant.
Constant. These two I'll take after that, and then again go through the rows.
No, no, it's not like that, right? See, if you see on line 17, first you stick with I is 0 if you think about it, right? So if I is 0, J will also will start from 0 all the way to 1 and 2, right? So it will compare 0 with 0 first, 0 with 1, okay, and 0 with 2, correct? So that will be the first iteration on the jth level. And then
Okay.
you will be going through always two columns from your line 22 to 25. Only two columns.
Okay. In the
Right. So in the first column will be as is. You are just going to look at that column. Correct. So whatever the values they are, that will be your current.
I printed
But
your
okay, but if I is greater than 0, it will always be 0. That is what you are saying. Correct. Okay.
yeah, I was
Yeah,
printed.
so it can be taken as the left and the right pointers for the column which we are considering at present, I and J. So I
Left
can be
and
the left
right.
pointer and J can be the right pointer at which the current columns are pointing.
But it is right.
And then,
There will be only two columns. No, it cannot be all of them together, right?
Yeah.
So I will be
yeah,
1
this is
and
why
J
we
will
are
be
using
1.
prefix sum.
Okay,
Yeah,
because we already have a prefix, so therefore the value will be okay. It will take the sum between both of them. Yeah, that makes sense. Okay.
Yeah, so you'll get your third vertex through this K.
Yeah.
INJ would give you the top left and the top right, and K would give you the rest
Mid,
two dimensions.
Mhm.
K will go through each and every row for those
Right.
two
So
columns.
when you are on this line number 22, it's like a 1D array. So basically, that would give you the like how long you can go or how deep you can go. So using that, you can determine the rest two vertices of your rectangle.
Hmm.
This will
Yeah.
take you deep
Right.
only, right? Deep only you
Yeah,
will
yeah, deep only. So
grow.
the bottom left and bottom right dimensions it will give.
Hmm.
Yeah, this is a very good approach. Yeah, very useful also.
It's like it's a pattern based on 1D itself. That's why, like, or
Yeah. Yeah,
But
there's another
we,
one. Yeah.
yeah, sorry.
Yeah, go on. Yeah, I was just.
No, that's correct. So we cannot do that with the 2D prefix sum, right?
Yeah,
I
I was
think
about to discuss on that only. I think it looks doable because we are essentially finding out the prefix sum only, right? So we'll have to use some extra space, and then if we make that array, uh, the prefix array for 2D matrices, will it not work if we then traverse on that 2D array?
Hmm.
hard to say. I mean, if
Okay, so let's take this example only, like example
okay,
one. So we are done with this method, okay?
yeah,
Or
yeah, yeah.
is there anything else? Because I left in between.
No, it's done.
Okay. So what would it be? So the first one would be 0 1 0 only,
So your
right?
2D prefix you are calculating, yeah, 0 1
Yeah,
1
yeah.
Can
0 1 1, and now
can
coming to
we write in the text the way you have written those, so we can actually compare that with the code.
sure, sure.
Oh yeah, you don't have a code. Sorry, yes, my bad.
Yeah, I don't have the code for that.
Okay.
Yeah, so let's do it the way you were doing. Annotate only.
Yeah. So this is 0 1 1, and this will be your 1, and
No, why 1 0 only? No.
0 plus
Okay,
1
okay,
is 1.
right. My bad. Yeah.
Yeah.
My bad. Yeah, it would be
Now
this only 0 1
so
1,
this
and
will be 3.
then it would be 3.
Yeah, and now this will be 3 plus 1 4, 4 plus 1 5
Yeah,
minus 1 4, 4. And now this will
right.
be 3 plus 1
4
4,
only.
4 plus 1 5 minus 4 itself. Yeah, and this will be 4 plus 4 8, 8 minus
4
8 plus
only.
0 plus 7.
No, why
Sorry,
7?
4 only. I missed it. I think.
Only. Yeah.
Yeah.
So what does this give us? So this gives us the sum of the rectangle, which is having the top left vertex as the 0 comma 0 cell, and the current one is the bottom right, right?
Hmm. Yeah.
So
This should be
now,
5. 5, I think I made mistake, right? 4 plus 4
no, it should be
8. 8
1 plus
minus
2 plus
3.
3 plus 4, 5 only, right? Yeah, 5, 5,
Yeah.
5. So
Yeah.
it's the
Got
entire
it.
matrix, right?
Mhm.
Yeah. So now what we can do with this? Uh, we have to find what is the target value?
Target
0.
value is 0 0. And I think this will be
0
3 only.
only.
Because 3 plus 1 4. 4.
No, this
No,
would
no.
be 4.
Yeah, correct. Go ahead. Yeah.
Yeah. So okay, I don't see the annotate option.
Target is 0, right? So what would you do?
Yeah. So what do we do next? Target is 0.
So you here you got a prefix sum of 0.
Let's
So
take target
definitely,
as which is 3.
okay, let's take 3.
Let's take target as 3 because I see a couple of matrices with target as 3 also.
Two
One
matrices.
of them is this the first 4, and yeah,
This one
in
and
fact
this one.
3. In fact 4 I see.
4, how did you see?
More than that, in fact. Yeah. And that square matrix, right? 0 1 1 1. I cannot annotate, so I'm just saying the first 4 cells.
Okay. Yeah, got it. This 4 cell and this 4 cell. Again, this bottom 4
Yeah, and
cell.
the below and yeah.
Okay, so yeah, what do you say here? Next.
Right. Why am I not able to annotate?
You tap on your screen twice. You should be able
So
to.
yeah, I'm looking to annotate first. I don't see that view option which is there.
But can you see at
So
least
you
at the
can say,
bottom?
No, I don't see. I see
Can
just
you make him
mute and
co-host, Shashank, so then he will be able to.
okay. Anyways,
yeah, you can say, we can annotate. Or
I
you
think if you
want to
make
share the
him
screen?
co-host, then he will be able to see it, I think.
You can share the screen. I think.
yeah. So all right. So basically,
Okay.
I can share the screen.
Yeah,
Okay.
share the screen.
Wait then.
Okay.
I have to open the question also. Right. So quickly tell me that array. What was it? 0, 1, 1, and what
1.
was the rest part, Shashank? 1 and 1, right?
Yeah, then
And
3.
here it was 3, I think,
4, 4. Then 4
and here
down.
4, and again 3 here,
4, 4.
4 down, and then 5, right? This was 5, right?
Yeah.
Okay, just a minute. Right. Okay, so we are looking for the target 3, right? So this is 1, this is 1. Let's focus on this one, the first one I drew. Okay, so it is this square, right? Let me use a different pen. It is basically this one. So if I do something like this, like I have the sum of my square, I have this square, right? So this 4 is what? 4 is the sum of this square, right? So if I subtract this, like you see what I'm saying, right? If I subtract, okay, let me just draw a broad diagram first. Let's say I'm looking for the sum of this square, okay? So I have the sum of this square, right? And I also have the sum of this square. Another, let me do it another one.
That is 0, right? That sum.
Yeah, wait. So I have the sum of this, right?
Mm-hmm.
Okay, I have this blue, and I also have this one, green one, and I also have this one. So what I'm saying is, if I subtract this purple one, this brown one, and this green one from the biggest one, which is the yellow one, so I get this, and this is what I want.
Mm-hmm.
So this is what I'm saying. So just subtracting all these things, what is there at the top of this, like this value, and then this value, and then this value. So this, if I subtract this from this bigger one, then as a result I get this, my orange one. Making sense?
Mm-hmm.
So yeah, this is the logic. I mean, this is what we can do with the 2D prefix array. So let's take this example only, okay? Let's say we are looking for, I want to find this square, okay? So what is this value? This is 5, okay? And then what do? So you first subtract what is here. So here I have 1, okay? So you remove the contribution of this. Let me know if I'm going wrong anywhere, okay? Then you subtract this part. So again, 1 plus, okay? So we are done with this removal, and we're done with this removal. Sure. Now I have to remove the diagonal one, right?
Yeah.
So
That is
this
0.
diagonal one. So what is that? That is 0, right?
Yeah.
Are you guys able to follow?
So you
But
are
I think
adding
remove the
one
diagonal
one.
twice.
Sorry. Yeah. So
Remove the
I'm.
diagonal one twice.
We removed it twice. You have to add once.
Yeah. So we have to add this. I was coming to that. We removed this diagonal one twice because once it was removed for this one, and once it was removed for this one. right? So you have to add this once. So I'll be adding a 0. So plus 0 effectively. So what does this comes out to be? 5 minus 2, which is 3. And this is what we want, right? So this is the sum.
But yeah, but
1, 1, 1.
So this is all about range query in 2D matrix using prefix sum. But if you need to generate the range or the leftmost part of the given submatrix and the rightmost part of the submatrix, then you need to iterate from each of the values of the column and row, and then we can decide the leftmost top index and the rightmost bottom index. So to generate all those again, we need to have, I guess, 4 nested loops, because for each of the nested first 2 nested
Right,
loop will
that is true.
determine the
That is true.
leftmost top index, and the other 2 for loops will determine the rightmost bottom index. After this, we can perform the range query in constant time. But again, 4 nested for loops will contribute to n to the power 4 factor.
Right. Let's come to the complexity later. But like, is everybody clear with this approach, or we need to discuss
Yeah,
more?
I think what Arshit is saying, is trying to see if we are able to do it with the 2D prefix. Yeah, so the time
Yeah, I
complexity is surely
understand
going
it
to be hit.
could be n to the
Or
power 4 only.
yeah, yeah,
Yeah.
yeah. I think what you are
Yeah.
saying, that is correct. But the problem happens, in this case, first you do a 2D prefix, correct? And still you are going to go and find
Mm-hmm.
again the sum of each and everything. So that is a lot of work, correct? Yeah, but this is doable for sure,
Right.
the
It
way
is
you are
good
saying.
amount of work.
Mm.
Yeah.
But I think there is a better way of
Yeah.
doing.
So my
Okay.
idea was like when you see this question, yeah. So what I was trying to say is that first we should pitch this approach n to the power 4 1, and then we should come to what Shashank has done. That is n cube.
Right. But still, in the same, the 2D prefix, you can still do it without, first you calculate the 2D prefix sum. But the way Shashank was doing, getting all those, fixing on 2 columns and then running through all the rows, that can also be done on this one, what you have done on this approach.
That can also be done.
So now you have 0, 1, 1, 3, 1, 4, those 2 columns, right? Okay.
Yeah, it
And
can be done.
yeah,
Yeah.
it can be done the same way,
Yeah.
what Shashank has done. But only thing is you first create the 2D prefix sum, whatever exactly you did it, and then just run the
Right.
same thing. That also should work.
Yeah, so it's like just keeping 2 pointers. So you keep 2 pointers here, okay, and then
Hmm.
you subtract 1 minus 0, 4 minus 1, uh, right? So
Right,
you
right,
get something
exactly.
that is the way he was doing,
Yeah,
and then you do that prefix, that hash map thing on that 1D array you get.
yeah. So then
Yeah,
that will be an optimized way. And then after this, Shashank's code will be more optimized, because we say that we will still remove the prefix sum, 2D prefix sum also, because that is not required. So we can do a 1D prefix on a row wise or column wise, whatever the way we actually decide on. So that will slightly
right.
reduce that time complexity there also.
Yeah, absolutely.
Yeah,
Yeah, it's a good build up. Yeah.
right. So then that makes really more sense what Shashank was doing, and then we can actually walk through that, and that is correct. Okay, yeah, Abhishek, you had some question, right? So what was that? He had something more optimized way of doing it, the range query way.
No, so I was just pointing out the how we are using the 2D matrix here as prefix sum. So we were using 2D prefix sum and then finding the range query. So for finding the range query, again we need to set the pointers for the submatrix, and the pointer has to be the topmost left index and the rightmost bottom index. So these 2 pointers need to be set for a given submatrix, and then we can find the sum using the range query of the 2D matrix. So, but the main problem with this approach would be, since we are generating the both the pointers, and since it is a 2D matrix, generating both the pointers would take n square for each of the pointers. So the 4 nested loop will contribute to n to the power 4 factor. So this is why to better optimize it, we could use that Shashank one, where we were using either the 1D prefix one and then using a hash map to check if the target has occurred previously or not, and then incrementing our answer.
Hmm. Okay. So that is the most optimized version, correct?
Yeah.
Okay.
Yeah.
Yeah, so this is using one of the questions, I guess, which is count of contiguous subarrays with some k. There's one question on Leetcode itself where we are counting contiguous subarray with sum as k. So there we are using hash map to find the final answer. So the same approach is done here, but since it is a 2D matrix, we need to use prefix sum again.
Mm-hmm. Okay, but can't we use any other approach like the index tree, the Fenwick tree, or something like that also on this one? But that will be a expensive one, right? Time complexity wise. I'm just thinking
Yeah.
loud.
Yeah. Anyways, we need to find some method using which we can find the sum of submetrics in constant time. So to do that, anyways, we have to do some pre-processing on the given matrix itself.
Mm-hmm. Yeah. So this will be the most, at least the better way of doing it now, right? Yeah.
Yeah.
Okay. In the meantime, we lost Shashank. Okay. Okay. So Harshit, do you have the code? You want to share that or?
No, I don't have the code.
Okay. You were actually opening something I saw then.
Yeah, I was saying that there's similar question where we do the same n cube thing.
Okay.
But
Do you want
the
to share that?
if yeah, I'll quickly
In
share.
the meantime.
Yeah, give me a minute.
Sure, sure.
Sorry. So here the question is that you have to find the maximum sum subrectangle in a 2D matrix. Okay.
Mhm.
So you do exactly what Shashank was doing, but instead of that inner loop, instead of that you just run your cadence algorithm
Yeah.
because you want the maximum sum in that 1D array. So,
Column wise, I mean every row wise, you on every row you
Okay.
have to
yeah,
do the balance.
right. So
Okay.
this is what he was doing, right? Two loops for left column and the right column,
Mhm.
and then you cumulatively add your elements. Okay, and then you pass this temp to your cadence function.
Hmm. Okay, so every time when you are actually going in that row, oh no, you actually do it for the whole row.
For the whole row between left and right.
Okay. Okay, so between left and right, and then you don't have a prefix sum. That is the reason you are doing all that, right? Okay. Mhm. That is
Yeah,
interesting.
so we just have this 1D array temp
Uh-huh.
which we make. Yeah, so let's quickly go through an example. Okay, so let's say our left is at this 0th index. Okay, and my right is at this index of -4. So what I'm doing is I am just cumulatively adding everything from here to here, like 2 -1 -4, and then -3, 4, 2. So at every like here I'll have 2, -1, -4, which is -5. Okay, and here I'll have something else like 6 -3, which is 3. So then in that 1D, and similarly you'll have 19 here. So you find your maximum subarray sum in that 1D array. Okay, so just remember this. What is this? -1 and -4 is -5, and this is. Wait.
So you are taking first row, one row, and then you are going, then you will be incrementing other rows. Is that what you're trying to say?
Yeah, sort of. Just a minute. So it would be the 1D array would be like -5 plus 2 is -3, and then it would be 6 -3 is 3, and then 19, and then 7. So what would be the maximum subarray? This one, right?
Okay.
So this one would give us, so this stretch of 1D array would give me the length, like this dimension. Okay, and right minus left would give me this dimension.
Okay, yeah. Yeah, that is one way, yeah. And this looks,
So yeah,
you don't
From
need
this-
extra space also.
so you return your start and finish from the cadence. Yeah, so you don't need anything extra. You can do it in place only.
Yeah.
Just return your starting and ending index from your cadence, and the left and right you already have, right? So these are the final values you'll have of that rectangle. So you can return that rectangle. You can print your rectangle then.
Yep. So they call this as a DP way. Okay.
Yeah, it's a good way.
Yeah, it's really good.
Worth going for. Yeah.
Because Shashank's way, surely the way he demonstrated is an optimum way. But coming to that, intuition is slightly we have to go. We have many different evolutions, right? Yeah. So this is just the standard Kadan's algorithm in a 2D matrix. Makes sense.
Yeah. So the broad idea is to convert the 2D into a 1D, and then try to apply things on that 1D array. All right.
Yep. Thank you.
So next is like picking iterator. So we have to design an iterator which supports the peak operation on a list in addition to has next and next. So it will initialize the object, next will return the next, and has next will check whether there is still elements left in the array, and peak will give you the next element without removing the point. So these three are the elements. So your next will give you first 1, 2, then peak will return the next element in the array without moving the pointer. That means you will get 2. And again next they are saying, so it has not removed, so again it will return 2 for this, and next will be 3 for this, and has next everything is empty, so false. Same thing. And generate, it should not work for until that's a follow-up. Okay. Yeah. So how do you see? Looks like more of a stack, right?
So the brute force one would be to first copy the given vector itself and initialize the pointer from the leftmost index, which is 0. And then for each of the function call, whether it is has next or has next, peak or next, like in peak, we just need to return the value at the given pointer. In next, we just need to return the value at the given pointer and then increment our pointer. So we can just increment the left pointer. If imagine if the pointer is pointing to 0, we can return the value at index 0, and we can just increment our vector index to 1. And then has next is just checking if our pointer does not fall out of bound. So it has to be always inside the 0 to n minus 1, where n denotes the total size of the list or container. So this can be a brute force one, where we first copy the given vector itself, which is passed in the uh, constructor, and then we can set a pointer which will move as and when required by the function definition.
So, but then how is the first beginning? When will be the first one actually, right? Then if you get a first next. I got your point about actually copying the whole into that array, the first one. So very first one when you get a call for next. So how do you initialize that the first pointer?
Yeah, so the first pointer will always point to 0 or the 0th index if it is 0-based indexing. Since we always start from the leftmost value in the given vector, since here the first next call is returning the first value in the vector, which is 1. And
So
then,
you're saying that is always initialized in that class. That is what we need to assume,
yeah,
right?
yeah,
Okay.
in the constructor, we can initialize it with 0.
Okay, in our constructor, so we can initialize, but we don't have any other way to do that, right? Do we have?
Yeah,
I'm just asking.
yeah. Yeah, I think uh, the pointer has to be initialized to 0 in the constructor itself. And then for each of the function call, we can just update the pointer.
Okay, so that will be done by the default. Okay.
Yeah,
Yeah, I understand that has to be there, or else it's not going to work for sure. It doesn't make sense, also, right? Yeah.
So you can maintain a map. Okay.
Yeah.
but
Yeah, that
then
is.
we are not using the iterator class, which is inherited in the picking iterator class.
Mm-hmm.
So if you see the declaration of the class of iterator, there they have used a struct data and a pointer. So they have two function inside the class, where the first one is next, and it returns the next element in the iteration, and there's again a has next, which returns true if the iteration has more elements. So I think we can use the base class here, which is iterator, to further optimize our brute force approach.
Mm-hmm.
Mm.
Oh, so in the first case, when you are talking about the brute force, you are not considering the iterator class at all.
Yeah, since we are copying the given vector, then we don't need any other class,
Okay. Okay.
We copy
Okay.
the
So
because
you are not
all
taking
the
it.
yeah all the operations will be anyways performed in constant time. Since we
mm,
just need to check if the pointer does not fall out of bound, or the value exists at the given index or not. So all this kind of operation are constant time. But again, since we are copying the given vector itself, it will be taking extra space.
Right.
yeah.
But anyway, the iterator class will surely do it, right?
Yeah.
You
So
have to
see,
copy that, or maybe keep a pointer. Yeah, a reference. Yeah.
yeah. So in the constructor of the iterator class, they have passed the vector itself. So if we see the constructor of the peaking iterator class, even there they have uh, pass the given vector nums as the constructor to the base class iterator.
Yeah.
So this means that we have already passed the given vector to the base class.
The
So
reference.
now
Yeah.
we can use yeah. So now we can use all the functions of the base class inside our this picking iterator class.
Mm-hmm.
Yes.
Yeah. That's right. And they have forced us to do that, right? Because that is the way they are showing that function signature also. The iterator
Yeah.
actually has been inside that. Yeah. Okay. We have limited scope to improve in that. Yeah. Okay.
I think I followed same what Abhishek mentioned. I've kept a front and an iterator, right? So it will point to none, and this will check whether has next will check whether there is what to say. Is there any next element in the in this list? If it is, then we'll assign that next element to this cell dot front. I mean, it will be pointing to this, right? And for peak, like front will always have the if element is there, then front will always be pointing to that. So peak will return you the cell dot front itself. And coming to next, I'm storing my front into a temporary, right? Because let's say one I took it. Now next will be what two, right? So and then again I'll make this front to none and we'll check whether next element is there. If it is, then to the cell dot front I'll take iterators next. I mean iterator initially will be here, the next will be this. It will take two and then return the temp. And regarding has just is a boolean function in which I'm passing front. If it is not none, it will return true. Otherwise false. The front is basically taken care of. If it is none, that means element is not there. Otherwise, if there is, then that will be stored in your cell dot front that point.
Can you just scroll to the place where you have that front and iterator declared?
Yeah. This is the instance. I mean,
Okay, you are actually assigning the iterator. Okay, so you have a different. Okay, the signature itself is different for you. Okay,
yeah.
and do you have something more? Okay, that's the only thing, right? The start of that. Mhm. So iterator class come here, and then you are actually storing that. You have to assign that. Okay, yeah, because you are not given that by default.
Default here we have to.
Hmm. Okay.
Yeah. And then you can switch to next.
Yeah, so this is how all the operations will be performed in constant time and without using any extra space here.
Yes.
Yeah, so the iterator class will also use the reference of the nums array, right? I don't think so. That's very
Yeah,
clear in the Python code, right?
Yeah, it will focus on I mean on the
yeah,
array
yeah.
itself. That's why we are able to take it dot next, right? It will be initially here.
Okay.
Then
Yeah, but where is the reference of that particular array you are passing in your constructor or anywhere in the speaking iterator?
Yeah, so in Python, I guess when the iterator was passed, so before iterator was passed to the picking iterator class, the iterator was initialized, or when iterator was first, when the object of iterator was declared first in the main function, there they already had passed the nums list as in the constructor. So they are not passing it again in the picking iterator class. In the
here you
yeah, so
initialize.
line 4 they have already passed it.
How can they do that?
So
Then
Hmm.
yeah, so in the main declaration when they were
Okay.
defining an object of iterator class, there itself they had passed the nums list in the constructor of the given class. So this is why they have not passed it again in the picking iterator class.
But that's not a good way of doing it, right? Because
Yeah, so here we cannot. So in the Python implementation, we cannot access the nums vector directly.
yeah.
But in C++, they have passed the nums vector in picking iterator class also.
Hmm. So it's like it's the iterator has been tied up to that nums always.
Yeah,
Correct.
yeah,
Uh,
yeah.
I don't know why they have done it this way, but yeah, okay.
yeah.
Yeah, but good to know that difference. Okay. So do you have that C++ or Java implementation? Anyone? Abhishek or Shashank?
Yeah, I've done in C++.
Okay. Can someone share, please? Yeah.
Yeah, so is the screen visible?
Mhm.
Yeah, so in C++, while declaring the object of the class, there they have passed the given nums vector in the constructor. And then since we are inheriting the iterator class, so here we have passed the nums vector again. And now
Mhm.
the whole code is similar to the Python implementation where we are declaring two variables, uh, the next value and the next and next, which defines if next value exists or not. So at any moment, if peak or has next is called, we just need to just return the next value and the Boolean variable and next, which determines if the next index is possible in the given list or not. And in the next function, here first we assign the answer to the value of the next index, and then we update the Boolean variable next. And if next exists, we update the next value. And since we are just updating the next value, but we need to return the value at the current index, which was already stored in the answer. So we return answer here. So all these operations are constant time. And in the uh, constructor of the picking iterator class, first we are assigning n next to the value has next. So this determines if uh, it returns to if the iteration has more elements. So if it has, so if n next has the value true, then we assign the next value as the the function next of the iterator class, which is being inherited in the picking iterator class.
Okay. So the function next doesn't increment the pointer.
Yeah. So next is so here they have done int next returns the next element in the iteration.
Okay. But it doesn't increment. I'm
Yeah,
asking
yeah,
a
yeah,
question,
yeah,
right?
yeah. Yeah, it
Okay.
does not increment, but in picking iterator class, when we are overriding the next function,
Mhm.
since next is already declared in the iterator class, but again, since we are inheriting the next iterator class in the picking iterator class, we need to override the next function here. Since in here it is mentioned that the next function returns the next element and also moves the pointer to the next element. So here we have to move the pointer also.
Okay. Okay.
So
So the
this
pointer movement is, oh,
iterator
sorry. Mhm.
base class is also given that. Is it that also given somewhere?
Yeah. Here they have given the declaration of the base class iterator.
Okay, and can you repeat the inheritance part? Like you are inheriting this next function from your iterator, that I understood. But I
Yeah,
mean, how are you handling
yeah.
the increment of pointer?
Yeah, for the yeah for finding the value of the particular iterator, we are declaring two variables here, which is next value and next. So and next value stores the value at the so this is the pointer to the next element, and n next determines if next element exists in the given list or not. And then in the iterator, first we assign in the constructor we first assign the n next value uh, to either boolean true or false uh, with the has next function of the parent class, which is this, and it returns true only if the iteration has more elements. So if it
So
goes out of
initially
bound, then
this
it will
would be
return
false,
false.
right?
Initially, for this, let's suppose we are taking this array, then why in the constructor n next will be true, since we have elements in the given array, and uh, yeah, so they have not specifically mentioned where the iterator is pointing, but the iterator will be pointing to the uh, left of the extreme left of the given array. So this means
Mm,
that for 1 to 3, when we will be calling n next, here it will show us that we have 3 elements left in the given array. So here it
mhm.
will assign it true, and now since it is true, the iterator next function will give me the next value. Since it is mentioned here,
Okay, got it,
returns the
got it.
next element in the iteration. So since my iteration will started from the leftmost part of the leftmost index, so it will point to the first element here, which is 1. So
Right,
this
so
is
it would
why
be 2.
when
First or second?
first, I guess, since the initial iterator will be pointing to the left of the leftmost index. So it is not
Okay,
pointing to 1, it is pointing to value left of 1. Take it as
okay.
any
Or the
imaginary
Uh,
index.
begin, yeah,
Imaginary value.
Yeah,
first begin.
yeah, yeah,
Okay.
Mm-hmm. Okay.
yeah.
Yeah, yeah. Got
And
your
then
point. Yeah. So
yeah, yeah.
this
And
iterator
then
is clear. Yeah.
yeah,
Okay,
and
so
then
it mean.
yeah, and then peak, they have mentioned return the next element in the array without moving the pointer. Since we already had assigned n value as the next value, so here we can just return the next value. Again in has next, it returns to if there are still elements in the array, which is same as n next, which we declared, and this is why we are just returning n next. But when function next is called, here they have specifically mentioned that return the next element in the array, same as peak one, but move the pointer to the next element. So if the pointer is pointing to 1, we will return 1, but the pointer will move to 2. So this is why first we store the answer, and then we just update our boolean variable which determines if next value exists or not. If it exists in the given list, we just update our next value to the next the value at the next iterator, and so it will be pointing to 2, but again we need to return the value at the current so we need to return the value at the current iterator which we already stored in answer, and then we updated next value, so we are returning answer here. So
Yep.
this is how all the operations will be performed in constant time. And since we are just changing the iterator uh, from left to right in each of the function call.
Yeah. So the next, actually, the iterator next moves the pointer, not the has next.
Yes.
Yeah,
They have not said very specifically anywhere, not even in
yeah,
the
yeah.
iterator class. But yeah, that makes sense.
Yeah, but
Yeah.
the
So
base class iterator does not change the uh, index of the iterator. So base class does not interfere with the movement of the current iterator. But the
Yeah.
peaking iterator class changes how the iterator will proceed forward in the rightmost direction.
But it is still taking the help of the iterator class, no?
Yeah, 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 yeah.
Okay.
right. So that is more like an abstract class, the
Yeah,
iterator
yeah,
one.
yeah,
Mm-hmm.
yeah. And again, we are overriding the functions of the base class. The next and the has next is again uh, declared in the peaking iterator class.
Is it? But yeah, they
So
have been
is it
maybe.
overriding is something else? Like as far as I know, then you use that virtual keyword, right, in your base
Yeah, yeah,
class.
yeah,
Yeah, that is not shown, but they are saying in that comment section. Okay. Okay.
yeah. Yeah, but anyways, if peaking iterator dot next is called, then we need to pass this function definition, not this function definition.
Yeah.
Right. You have to override this. Yeah.
Yeah,
You
yeah,
have
yeah.
to.
So this is why I was telling about overriding. But
Mhm.
yeah, yeah, we use virtual keyword when we use this uh, overriding in runtime polymorphism.
Yeah, that has to be. Yeah.
Mhm. Yeah. Anyways, good one.
Yeah. All right, I will just stop sharing.
Yeah, thank you.
Yeah. So next is like, we are given an array and we have to return whether, like what is it, two values are the same number of occurrences or not, right?
Mhm.
Like if one has three occurrences, two has two, and three has one. So all of them are unique. I mean, none of them should have what is it, same number of occurrences, so true, but yet they have same number of occurrences, so false.
Yeah. So this is the first time they are asking us something different, right?
Yeah.
It's almost a
Yeah,
similar
Sushant, can you
sort of
scroll up? I
problems.
didn't read the question. Okay, got it.
So now it's not asking us the unique number, but it's asking the occurrences unique number.
Oh, yeah. So
Yeah.
that is also like map. I mean, normal map we can take and just uh, check their frequency, right? Whichever, if any of the keys is having same, then we'll return from there. We can
Right,
return
right.
that.
So that is what exactly has to be done, I think. Yeah, there might be a brute force way also, but it being an easy question, we can actually jump to this optimized solution what you're talking about. But now in this map, if you actually build up this frequency count, right? So now you are actually going to play on the frequency count in this case, right?
Yeah, that is what like if
Mhm.
it is repeated, I'm increasing the frequency and taking the set count, and at last it will check the length of set count and these are equal. Then we are
Yeah,
it will return true, otherwise false.
yeah. So this was if they didn't ask us to do anything with the frequency count, then it was super simple problem. They would never ask it.
Exactly.
Okay.
And there is no other method of, uh, so there is no method other than finding the frequency first and then doing the
You can
processing.
do XOR operation. If the XOR is zero, resultant XOR is zero. No, that will
Yeah,
not. That won't work.
yeah.
No,
Here,
if you have
yeah,
even
here.
numbers, then that won't work.
That won't work.
Yeah, this is the only way to go, right? Huh.
Yeah, you need the count anyway, right? You need the
Hmm.
count of
Yeah,
every number before you can do anything. So I was thinking of that
yeah.
bucket
So,
sort, but
anyways,
again, you need the count.
Hmm.
yeah. So, anyways, we need to find the frequency. Either way, if we do it using map, or either way, we use the concept of counting sort where we use the index as the frequency table itself.
Okay, yeah. Now, oh, that depends if you have the array size and all that stuff, right? The constants also. Okay.
Yeah, so the values are given in the range -1000 to 1000.
Hmm.
So we can just shift -1000 to 0 and +1000 to 2000.
Yeah, that way we can do it. Yeah.
Bitmap kind of.
Yeah, so
Hmm.
then we can use the idea of counting sort where
Hmm.
we first find the frequency using another array where we store the frequency of all the. But anyways, we need to find the frequency. So
Hmm.
using map will be more. Uh, so using map it will be more easier other than using another extra array and then shifting the pointers.
Yeah, makes sense. Okay.
Yeah, map is cool, but I think as per my experience in interviews,
Mm-hmm.
they people they like if you use something as per the bounds. So if it's like an alphabet sort of input, then they would prefer that you use a 26 size array sort of thing.
Okay. Uh-huh.
Yeah. So because map is a universal thing, map would always work. But
Uh-huh.
since this involves some analysis of the input given, so that's what I have experienced, that they like people who go by the inputs and make your auxiliary space according to that.
Okay. So then you're saying the way Abhishek was saying that will make more
Yeah.
sense to go with. Okay. Hmm. Good
So
to know.
first step would have been the hash mapping only.